Okay, hello everyone, welcome. Can you hear me? Okay, thank you. Just we're waiting 1 minute, then we'll start. Okay, so we'll start today's session. So basically, today is our seventh number day for this online training program. Okay, so basically today's session we will discuss about that how we can easily make the change detection analysis using Google Earth Engine. So today's session we will discuss about that mainly land use, land cover change detection using Google Earth Engine. We talk about that NDVI change detection as well as NDVI classification, how we can easily make the classification using the different types of range value, and extract the dense vegetation using threshold technique. We also discuss about that. And class wise land use land cover change detection in one level, also discuss about that. And calculate the transition land use land cover area, we also discuss about that. And also discuss about that urban development or urban growth monitoring, how we can easily make that urban growth monitoring, urban expansion mapping. Okay, and also discuss about that hyper parameter tuning, mainly hyper parameter optimization, and it also improve your accuracy level for your land use land cover classification. We also discuss about that. Okay, so now here I already created this one kind of map for the 2 decade of land use land cover classification. So if you check this map, this is the map. So we try to classify land use land cover year of 2013. So this is the map year of 2013. As well as also this is the another year of 2023. So this is the map year of 2023, and this is the map for 2013.
Sir, excuse me, sir.
Yes, please.
Sir, your screen is not visible.
Okay, just okay, let me share please. Thank you. Just a minute. Yeah, so yeah. Okay, now can you see? Okay, thank you.
Yes,
Yeah. Okay,
yes,
okay,
yeah.
thank you. Okay, so here you can see this is the two land use land cover we already created for 2 decade. And previous class I already discussed about that how we can easily make the land use land cover classification for 2 decade, mainly 2013 to 2023. So if you check it, so this is the map land use land cover 2013, and this is another map 2023. Okay, so now between these 2 decade we try to make the change detection. Okay, and also try to calculate how much area increasing or decreasing, how much area we try to calculate. So basically it's classified the mainly vegetation. Okay, green color indicating about the vegetation, then blue color indicating about that water body, then this is the sand, this color indicating about the sand land, and red color indicating about the build up. Okay, so we find out this type of map. So now between these two map we try to check the change detection. Okay, and also calculated how much area increasing or how much area decreasing. Okay, and also created the change detection map between the two decade 2013 to 2023. So let's go, and I hope you already know about that how we can easily make the land use land cover classification, mainly supervised classification. I already checked the accuracy. This is the map. We find out the 98% and overall accuracy for the 2023, and this is the 2013 96%. We already checked the accuracy. Okay, as well as also calculate the area for 2 decade land use land cover. So this type of things you already know because we already discussed about this topic for the previous class, how to make the land use land cover classification using Google Earth engine. Okay, mainly supervised classification. Okay, so you can simply create your own study area. So you can see, first of all, I take this satellite imagery for 2013, and this is satellite imagery for 2023. Okay, further we simply take the training sample. Suppose you can see this is the vegetation, water, sand build up for 2013. Also take this training sample from year of 2023 images for vegetation, water, sand and build up. Okay, then further just make this type of classification 2013, and this is the classification for 2023. So now we try to discuss about that how we can easily make the change detection using this 2 decade land use land cover. So basically we do the two types of change detection analysis. One type is for multiple class. Multiple class mainly it's including all of class at the same time. Suppose I just focus all of class, vegetation, water, sand, build up. Okay, so it's called the multiple class. At the same time I just perform the analysis, mainly change detection analysis for the total 4 classes: vegetation, water, sand and build up. So this is the one way. Another way is that you just focus only for the one class. Suppose my concern only for that urban area or build up area. Suppose I want to make the change detection analysis only for the build up area. I want to monitor suppose urban growth. Then we talk about the only for the single class classification. So single class and multiple class change detection. So two types of change detection we can easily do using Google Earth Engine. So I will show you the both of how we can easily make the single class change detection as well as also multiple class change detection using Google Earth Engine. Suppose in this case, I want to focus only for the urban. Suppose urban class. Suppose this red color is the urban. So this is the urban scenario in year of 2013, and this is the urban 2023. So now how much urban is increasing and how much area loss. Okay, so this type of things how we can easily calculate and also make the urban change detection map. So now we talk about that how we can easily create this type of work. So first of all we need to check which variable stored this land use land cover map. Okay, so if you check it, so here you can see basically this is the land use land cover 2013. This is the layer name 2013, and it is stored in this variable classified. Okay, so mainly classified this variable is stored the land use land cover map 2013 and LULC 2023. So this is the layer name. So this layer is stored in this variable classified 1. So classified it stored the year of 2013 and classified 1 it stored the year of 2023. Okay, so you just simply check your variable name when you work with change detection. Basically this variable further you also use. So in this case for my code, land use land cover 2013 is stored in the classified variable and land use land cover 2023 this map is stored in the classified 1. Okay, so then further we just use these two variable and make the change detection. Okay, so let's go. First of all we discuss about that multiple suppose single class change detection. Suppose I want to focus only for the urban change detection. So these things you can also apply for any other classes. Suppose vegetation or water body or any single class. You want to make the change detection analysis for your specific time period. So in this case I choose for urban change detection. between 2013 to 2023. So first of all, I need to create the single class map. Single class map mainly, suppose I just create the one kind of map. This map display urban and non-urban. Okay, just only for the two class, urban and non-urban. So how I can create this type of single class map? So let's go. So for that, first of all, you simply check your variable. So we already checked the classified one. So this variable stored the land use land cover map 2023. Okay. So just I take a normal variable. You can put any name as a variable. I put the variable name, suppose build up area 2023. So this variable I just store it. Classified one mainly land use land cover 2023. Okay, and set equal to 3. So what is the 3? Mainly this 3 come from your level. Okay, we already know about that. Vegetation, you can see what is the level. Level is the 0. If you check what is the level for water, it's a 1. Then check what is the level of sand, it's a 2. Then what's the level of build up, it's a 3. So build up is the 3 level. Same as also for 2023, if you check vegetation is the 0, then water is 1, then 2, build up is the 3. Okay, so build up is 3. So now I want to create the only for the urban class map. So that's why I simply put here the equal to 3. Okay, equal to 3, because 3 is the level of urban. Okay, so now this variable is stored only for the urban class and non-urban class. This variable is stored. Suppose you want to work for the water body, then put here the water body level. You want to work for sand land, then put here the sand land level. So we can easily say, get the level from here. Just click on here, you can see we can find out the level is the 2. So when I work with sand land, I simply put the level is 2 and then work. So in this case, I want to work for the build up. So for that, I put here the equal to 3. So classified one, basically this variable is stored the full land use land cover 2023. Okay, this map is stored all of class. From all of class, I set only for the one class. This class is for build up, and build up value is 3. So that's why we just put here the 3. Okay, so now build up class is stored in this variable. So further we try to display, basically we try to display as a binary class. Binary class mainly 0 and 1. Okay, just call this variable name and paste here and set 0 and 1. 0 and 1, 0 mainly non-urban, 1 mainly urban. Okay, and we display, suppose non-urban show as a gray color and urban show as a red color. Okay, and we put the layer name urban 2023. So now if I run the code, then it added the another layer. This layer display the urban area year of 2023. We find out. So you can see it's created another layer. So now it's loaded. Okay, just keep me only for this layer. So now you can see find out the red color. It's indicating about the urban, and this gray color indicating about the non-urban area. So we are just creating only for the one class map. So now we try to check how much area, suppose how much urban area is available in the red color. Urban area, how much area, we try to check it. So for that, just take a variable. Suppose I put the variable name is that urban area and call this build up area 2023 and multiply with this function. So this function mainly calculate the pixel area in a square meter. So when you calculate the pixel area, then we simply call this function, and further we calculate the area, suppose total area. So for that, just simply use this code. So just I uncomment it. Just take a variable urban area 2023, then call it urban area and apply the reduce region. And lot of time we already use this function reduce region. So reduce region function, basically when you calculate any pixel value, suppose total pixel value or average pixel value or maximum pixel value for a specific boundary, then we have to use the reduce region function. And in this case, reducer, I want to calculate the total area. So put the e.reducer.sum, then import your study area, then your resolution, And max pixel, basically when you work with the big study area, then we need to put at the max pixel value. So further just print it, then we can easily find out how much build up area is available in year of 2023. We can find out. It's computing. So if you check the value, then we can find out it's very long value. Okay, basically this is the square meter unit. Okay, so further if you want, you can convert, suppose a square kilometer or hectare or any specific unit, you can simply convert. So for converting, first of all you check, this is the keyword classification and this is the value, mainly number. So this is the keyword and this is the key value. Okay, and these things, this is it's work as a dictionary. We find out the dictionary, keyword and key value, and this variable is stored this dictionary. Okay, so now I want to convert, it as a unit. Suppose a square meter to a square kilometer or hectare, I just try to convert. So conversion, just take a variable, and you can see it's a number. Okay, so when you define any new number, we have to use the function e dot number, and I call this variable, basically this variable which is stored this number, and this number I get from this key value, sorry, keyword. Okay, classifying the keyword. So then put here the get classification and then divide it. So when you divide it, 1 into 10 to the power 6, mainly scientific notation 1 is 6, then it convert as a square kilometer. Okay, we find out that is a square kilometer. So this is the variable, this variable is stored the dictionary. Okay, you can see the classification and this number, keyword and key value. So then put at the get this value from this classification, put the classification this keyword and divide it this value. Okay, then we can get the result, a square kilometer. So now try to check it, just print and run it. So now it's computing in a square kilometer unit. We find out the result in a square kilometer unit. So you can see how much area in the urban or build up. We find out 824.99 square kilometer area of urban. We find out. Okay. So this is the way. Suppose I want to work for vegetation. So how I can change it? So for that, simply put here the value or level of vegetation. What is the vegetation level? Level is the 0. Okay. Just put here the 0. Just put here the 0. Then I want to display the vegetation as a green color. Okay, we can put any color. Suppose I put here the green, and further just run the same code. Then we find out that how much area in vegetation in year of 2023. Okay, so and it also display the vegetation and non-vegetation map. We find out in year of 2023. So if you check it, this type of green color, it's indicating about the vegetation area, and this type of gray color indicating about the non-vegetation area. And how much vegetation area, it also computing in here. So it's working. So if I don't,
Excuse me,
yeah, please.
can you apply the same process for other index like BSI or other index, or we must pass?
Okay, so basically change detection. So this is the land use land cover change detection. We have the another change detection, NDVI or BSI change detection. Okay, or index, suppose index wise change detection. How we can easily perform. Suppose NDVI or BSI or any other index wise change detection. Okay, it also possible. Suppose how we can easily make the NDVI change detection. Suppose I have total 2 decade NDVI map 2015 to 2020. So further we just simply check what the NDVI changes between these two time period, or BSI how much change specific to time period it also possible. So this thing also discuss after completing the land use land cover classification change detection, then you can easily get the idea. Okay. So let's continue. Yeah. So now you can see here we find out that vegetation. So this type of place we find out the vegetation, basically green color. It's indicating the vegetation in year of 2023. And how much area? We find out the total 49.78 square kilometer area. Okay. So now when you work with single class map, just simply put your value, any value, we can easily find out how much area, and also create the single class map. Suppose urban and non-urban, vegetation and non-vegetation, barren land, non-barren land. Okay, so any classes single map, just put at the value, then it make the map. Okay, so in this case we try to discuss about the urban change detection. So just I keep for 3 because I can see build up or urban is that value is the 3, so just put at the 3. And I want to display it as a red color, so put at the red. And then all of the same, just run the code, so we can easily get this result for urban, how much urban area we find out that. So after doing this thing, the same process we also apply for 2013. Suppose I want to calculate, so this urban map 2023. So now we calculate the urban map in year of 2013. Okay. Suppose in year of 2013, how much urban area is available? Okay. So for that, just apply the same process. For this same code, we need to apply again. So let's go. I try to show you that how we can easily work with the same process. Just apply. Then we just put the build up in year of 2013. So I take the variable. Suppose build up area 2013, then classified. Okay, because this classified variable stored this map land use land cover map 2013. So just I call it and set equal to 3, and then just map add dot layer. So then we can easily find out that urban 2013. So now if I just run the code, so it create the another layer only for the urban in year of 2013. Okay, so you can see we can get the another layer urban 2013. So you can see this is the urban, this is the map in urban and non-urban in year of 2013. So if you check it, this is the 2023 and this is the 2013. Okay, so now let's check how much area in urban in 2013. So same code we try to use in here again, and then check how much area. Okay, so for that, just take a variable. You can put any name as a variable. I put the variable name, suppose urban area. Just call this variable name, multiply with this function, and further just simply display the same code we try to use in here, and then display the area. So now just run the code. So here you can see find out that urban area in 2013 586.44 square kilometer, and this is the urban area 824.99 square kilometer. So we find out almost 238 something, 238 square kilometer urban increased. Okay, between this two time period. And I want to display, suppose I want to display this map. It's called that urban sporal mapping or urban expansion mapping. We also try to display also in Google Earth Engine. So for that we need to create the single layer. Okay, so it's called the binary meaning two class. So in this case it display the urban and non-urban, and also you can see when I open it, it also display the urban. Red color is the urban and gray color is the non-urban. So now if I just remove this non-urban class from both of layer, then we can easily find out the expansion. We can easily find out that which urban in 2023, which urban in 2013. We can easily find out from here. So let's go how I can make the single class from the binary class. So it's very easy. So for that, just use a function. We already use it. It's called the self max function. Suppose if I just put here the dot self max, and further just remove these things, it's not need, just remove, and I just create only for the class for urban. Okay, gray is not, we just remove the non-urban is just remove. Same as for these things, just put here the dot self max, and then just remove the binary class, it's not need. Now we can get only for the one class of urban 2013, only urban. Okay, suppose I want to display it the another color, then we can easily find out the differentiate between the two layer. I put it as a suppose yellow color. Okay, so yellow color display the urban in 2013, and red color display the urban in 2023. So let's go try to check the both of layer. So here you can see we find out this type of result. So basically this yellow color indicating the urban in 2013. Okay, and this type of red color we find out that this is the expansion area. Now when I open this map, so now we find out that this type of place newly set up urban area. We find out this type of red color indicating now. Okay, it's a newly set up urban area. We find out in here it's a newly set up urban area. So this type of red color urban area is not available in year of 2013. Okay, 2013 is only available this type of yellow color urban area we find out. Okay, but this type of red color we find out in year of 2023. Okay, so this is the expansion or urban sprawl. We find out this type of region in between this two time period 2013 to 2023. Okay, so this is the one kind of way we also visualize from here. Just use the self max function. Okay, so further if you want, you also try to make the change detection. Okay, basically in this case we find out that just we simply subtract 824 and 586, we find out that 238. Okay, 238 newly urban area we find out the 238. So let's go try to do it how we can easily check. So for that again make the binary class. Just I make the binary class again. But when you visualize the urban expansion or urban spiral for the different year, so in this case I just show only for the 2 year. But if you want, you can also put here the more than 5 years or 6 years or 3 years or 4 years. Suppose 1990, 2000, 2010, or 2020, then it looks more better. Okay, so now we find out this type of things. I want to check, suppose, urban change detection. So for change detection, just take a variable. I put the variable urban change map. You can put any name as a variable. Call the build up area 2023. We already take this variable. You can see build up area. Just call this build up area 2023, because this variable is stored the build up area 2023. Okay, just call this variable, and then just apply the subtract function. Okay, just call the subtract function, and then put here the build up area 2013. Okay, 2013 we put in here, and then self max. So basically in this time we find out only for those area which have the r1, increase the r1. Okay, mainly 238. Okay, just subtract this two value, 824 subtract with 586, 238 something area we find out. So let's go try to display. Just run the code. So if you check it, okay, this type of pink color, now it's indicating about the urban changed area. We find out that. Okay, so this type of place is newly set up urban area. There was no urban in 2013. Okay, and how much area in here? Okay, how much area? So we already know about that. So simply subtract. We find out that 238. Okay, simply subtract the value from 884 to 586. Then we find out that 238. So now we find out the 238 area. Okay, 238 square kilometer area map we find out in here. This type of place. Okay, this is the newly set up urban area we find out in here. You can also compare it. Suppose just open 2023, so you can see this type of place. Okay, it's a newly set up urban area, this type of pink color. Okay, but this type of this type of red color, it's indicating about that unchanged area. Suppose in year of 2013 there was urban, and 2023 also there is urban. Okay, there is not need to change, so it's unchanged area. So this type of place is the unchanged area we find out. But this type of place, you can see this type of pink color place, it's indicating about the changed area. We find out that there was no urban, but in 2023 we find out the urban. Okay, so this type of red color, it's indicating about the unchanged, there is no changed urban area. But this type of place we find out the changed area. So basically it's a newly set up urban area. And how much area? We find out that 238 square kilometer. Okay, and both of layer, all of layer, you can easily export. Okay, and further you can also make the more better map using ArcMap for your research paper or for your research presentation. Okay, you can also make the map. Okay, so just simply subtract, then we can easily find out this type of result. So now if you want to check how much area, we find out, we already know about that. Just simply subtract, then we can easily get the value. But these things you can also calculate also in here. So for that, just simply call this variable name and calculate the area. So just call the urban changed map, just call this variable name, and then put here that multiply with this function, and then just calculate the area, calculate this area. In this case, if you check, I put here the 100 meter. But if you just try to put the 30 meter, then check what is the problem. Because when you work with some big study area, there's a lot of pixel, so then we face some problem. If you check it again, now try to check what happened. Okay, so now it's work. Yeah, so you can see, find out the 586. Okay, same. So basically just put it 30 meter. 30 meter mainly our satellite image resolution. Okay, so just put it at the 30 meter, then we can get that accurate value. Okay, but sometimes you also face some problem, that the lot of pixel, this type of problem, then try to increase the value. So that's why then we also get the some different value. But in this case we just get the accurate value, because this calculation, uh, suppose, okay, just print it. Sorry, just print and then check what happened. Maybe we find out the 238 extra urban area, 238. Okay, you can see it show the problem. User memory limit exist. So this is the one kind of limitation. In this time it not just it. If I just increase the value, suppose I calculate using the 100 meter pixel size, consider, and then calculate the area, then check what happened. So now it's okay. If you check, you can find out the result. Okay, just try to convert into a square kilometer. So just use the same code, take a variable, and then call it urban changed, and then get from classification, because you can see keyword name is the classification, and divided with this value, and then print. So then it display the result at square kilometer unit. Okay, so now I can see we find out this type of 356. Okay, because in this case we consider 100 meter pixel size. Okay, so that's why it also show this type of wrong value. But when you keep it 30 meter, then we find out the accurate value. Okay, we find out the 238, but now it show the 356. Okay, because in this time we are just increasing the scale value. So just it take this type of excel scale value and further calculate the total area. Okay, suppose if I just put at the 60 and then check what happened. So let's computing. So if I run 357.23, okay, when you consider the 60 meter pixel size. Okay, and if you the 30 meter, then it show this type of problem, user memory limit exists. Yeah, so this is the problem. This is one kind of limitation. When it across this type of limit, then you face this type of problem. Okay, but if you increase the scale value, then it also show the value, but this value is not accurate. Okay, so that's why we face this type of problem. Okay, so if I just put here the 60 or 100 meter, then it consider, then it reduce the pixel size, mainly reduce the pixel number. Okay, so when I increase the pixel size, then it reduce the pixel number and compute the total pixel area. But when I increase the pixel size, then it will be worked, because if you increase the pixel size, mainly scale size, if you increase, then pixel number will be decrease, and then calculate the area. Okay, so you can find out this type of area. Okay, and then so this is the process to work with single class, how much we can easily create this type of single class map change detection. So any, not only for the urban, you can apply this type of things also for any other single class when you monitor change detection, basically 2 time period or 3 time period, then you just apply this type of things. So in this case, you're just consider only for the 2 decade, 2013 and 2023, but you could also added the more land use land cover classification map, and also make the temporal change for the different time, different year. Okay, okay, so anyone in question, you can ask me please, for single class change detection. Okay, I hope there is no question. Okay, so let's go. So now we talk about that multiple class change detection, not only for the single. At the same time, we try to discuss about the all of classes, as well as also calculate the transition area. Suppose water to water, or water to build up, water to barren land, water to sand, or sand land to build up, sand land to vegetation, or vegetation to build up. So this type of transition, how we can easily calculate, and how much area will be changed. So this type of things, it also possible, we can easily calculate. So it called the transition, one class to another class. Suppose water to build up to water. So this type of things, how we can easily calculate, as well as also make the change detection between this 2 time period, from year of 2013 to 2023. So let's go to discuss about that. So it's called the multiple class change detection. You can apply it for any land use land cover classification. Same code we try to use all time. So first step is that we need to make the reclassify. Okay, reclassify the value number. So previous time when I make the land use land cover, we just put the value. You can see 0, then 1, then 2, then 3, also 0, then 1, then 2, and then 3, and make the 2 decade land use land cover classification 2013 to 2023. So this same, in this time we are just make the reclassify. Okay, suppose now 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4. So vegetation 1, then water is 2, then 3, then 4. Same for 2023, just make the reclassify their value. Okay, so this reclassify we need, because further we also use it for make the multiple class change detection. So let's go try to do for the reclassify. Basically reclassify the value number from 0 to 3 to 1 to 4. Okay, suppose this 0 will be 1, then this 1 will be 2, then 2 will be 3, 3 will be 4. Just make the reclassify both of land use land cover classes. So this is the land use land cover classes. Okay, so just we make the reclassify. So for the reclassification, just I take a variable. Suppose before class, I take a variable before class. Before class mainly year of 2013, and after class mainly 2023. Okay, just put the variable before class and after class. Okay, just we put here the classified and classified one. Basically classified, it stored the land use land cover map 2013, and classified one is stored the 2023. And then we put the remap function. Remap basically it used to make the reclassify and put the previous value. Okay, just make a list and put the previous value. So previous time we put here the 0 1 2 3 and then make the new value. Okay, just put the new value 1 2 3 4. So now 0 I convert into 1, 1 convert into 2, 2 convert into 3, 3 convert into 4. Okay, so now this variable stored the land use land cover map in 2023 2013, sorry, it is 2013. Okay, and this is 2023. So now when I just apply this type of remap function, now this variable before class, this variable stored the land use land cover map, and this class will be 1 2 3 4, 1 for vegetation, 2 for water, 3 for sand, 4 for build up. Okay, when I just make the reclassify using the remap function. So just we make the reclassify both of land use land cover classification map. Okay, just call the classified and classified one who is stored the 2 decade land use land cover map. So if you check it, when I created, I put this type of variable. You can put any name. So you can see this is the classified and classified one. Okay, so classified and classified one, just we simply put in here. You can see the classified one basically 2013. Okay, so this is the after class, and 2013 is a before class. Okay, before, and this is the after. So this is the before, this is the after. So we just put this type of variable, so further we can easily get the idea. Before class and after class. Highlight it. Yes, so just simply before class and after class I put the variable and call the before class. Okay, basically 2013, and after class basically 2023. Okay, just I call this variable name. This variable is stored the land use land cover classification map, and use the remap function for reclassify the value. Just make the list and add the previous value, and then add the new value. Okay, so now 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4, same as for after class. Okay, just we take this two variable. So this is the first step. We need to make the reclassify 0 to 3 into 1 to 4. Or if your class is the suppose 0 to 4 or 0 to 5, then also increasing 1 to 6 or 1 to 7. Okay, so in this case we have only 4 class, mainly 0 1 2 3. So that's why we find out the 1 2 3 4. Okay, if your class is also increase, then you also just convert, mainly reclassify. Okay, so now just simply if you check, just subtract after class and before class. After class mainly 2013, before class mainly 2000, sorry, after class mainly 2023, it's a 23, and it's a 2013. Okay, just simply subtract these two things, and further if you just add the layer, so now it's create the one kind of binary class, and it just show the overall changed and unchanged. Okay, we find out the overall changed and unchanged, it indicating. Okay, white color mainly unchanged, red color mainly changed area. We find out that overall change, not for a specific class. Okay, overall changed and unchanged area. So now this red color indicating about the changed area, and white color indicating about the unchanged area overall. Okay, including all of classes. So now it's including about that overall changed and unchanged. So this type of white color indicating about the unchanged area. Okay, suppose this place was built up and 2023 it also built up. Suppose this place is water and 2023 is also water, so that is not changed, so it's an unchanged area. But this type of red color, it show the changed area. Suppose this colors, it was vegetation, but 2023 it was build up, so it's a changed area. So now it show the result, basically changed and unchanged area, okay, between these two time period 2013 to 2023 we find out. Okay, red color about the changed area and white color is the unchanged area between these two time period 2013 to 2023. Okay, so further let's discuss about the specific classes, how we can easily find out. So now we just try to calculate suppose transition. Okay, basically suppose water to water, how much area convert, or water to how much water body convert into vegetation, or how much vegetation convert into water body. Okay, so this type of transition we also calculated in Google Earth Engine also. So if you check it, so here you can see it shows some this type of things. You can see suppose 2013 vegetation to 2013 vegetation, suppose how much vegetation in 2013 convert into vegetation in 2023, how much vegetation in 2013 convert into water in 2023, how much vegetation convert into sandland in 2023, how much vegetation convert into build up in 2023. And you also set this type of code 101, 102, 103, 104. So basically this type of, it's called the class. Suppose 101 mainly vegetation to vegetation, okay, 102 vegetation to water because water is 2, 103 1 is vegetation, 3 for sand, mainly vegetation to sand. Then build up mainly 4 because we already make the reclassify 1 to 4, so build up is the 4. So we find out the 104, it means that vegetation to build up. Okay, and it's a before class 2013 and it's the after class 2023 is the after class. So now this type of 101, 102, 103, 104, it's called the transition. Okay, it's a transition, same as 201, 201, 202, 201, 203, 204, it also transition. So 202 mainly water to water, 201 mainly water to vegetation. For my code you can see it's a 2, okay, water is the 2. So 201 mainly water to vegetation, 202 mainly water to water, 203 mainly water to sand, okay, 204 mainly water to build up. Okay, build up is the 4, water is the 2, mainly 204 mainly water to build up. Basically how much water body convert into build up in year of 2023. Okay, same as 301, 302, 303, 304. Okay, 3 mainly for my case sand. Okay, sand to vegetation, 301 sand to vegetation. Then 302 mainly sand to water, 303 sand to sand, 304 sand to build up. Okay, same as for others, 401, 402, 403, 404. Okay, so it's a transition, build up to vegetation. 401, 4 is build up, 1 is vegetation. Okay, and this left side always will be before class. Okay, and this right side always will be after class. Okay, just remember that it's a before class, it's after class. Okay, before mainly 2013, after mainly 2023. So now how I can generate this type of value. Okay, so I need to generate this type of value 101, 102, 103, 104. So that's the region I just make the reclassify. Okay, simply I remove the 0 class. Okay, 0 I don't need. Okay, 0 don't need. So for that we just convert, mainly we just make the reclassify 0 to 3 into 1 to 4. So 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4. Okay, just make the reclassify it because I need this type of classes 101, 102, 103, 104. So now how I can find out this type of value? So for that we need to calculate the transition. Okay, for the transition we need to apply a formula. If you check the formula, So this formula basically before class we call before class. What is the before class? We already make the before class. You can see we just make the reclassify and make the before class in here. So this before class, it stored the value 1 2 3 4, 1 for vegetation, 2 for water, 3 for sand, 4 for build up. So we are just call the before class and then multiply with 100. Okay, multiply with 100 and add with after class. Okay, after class mainly year of 2023, and same 1 2 3 4 class 1 2 3 4 because we already make the reclassify. So now rename it as a transition. Okay, just we rename it as a transition. Further, if I check it, if you check it, just run it. Okay, if you check it, okay, just a minute. Yeah, okay. Where is it? So now if you just print, we find out, you can see it computing. It's an image, okay, and it's a one band. Basically, this result when I merge, and if you check this value band, if you check, it's a transition because I put the rename as a transitions, and it's an integer value. You can see belongs with 101 to 404. Basically, it means that it including 101, 102, 103, 104, then 201, 202, 203, 204, then 301, 303, 302, 304, same as 401, 402, 403, 404. It means that, okay. So now we find out all of transition when I just apply this formula. Before class mainly year of 2013, multiply with 100, add with after class, then we find out this type of value. And what is the 101, 102, 103? You already know. Okay, you can see 10, suppose 101, this means that how much vegetation converted into vegetation in year of 2023. 102 means that how much vegetation convert into water in year of 2023. How much vegetation convert into sand. 103 means that. 104 means that how much vegetation convert into build up in year of 2023. And this right, basically left value is the class number of 2013 or before class, and this right value, it's indicating about that after class mainly 2023. Okay, so now suppose 203 means that water 2013, how much water convert into sand 2023. Okay, so it's a transition we find out. So now, okay, the same things I'll write in here, but it will be different when you want to change your class value. Then it also just different for your own work. When you just apply this type of code, you need to check it for the transition number or transition class, you need to check it also. So now after doing these things, we try to check pixel number. Okay, suppose how much pixel number convert. Suppose 101, how much pixel number. 102, how much pixel number. 103, how much pixel convert. Okay, this type of things we can easily calculate using the frequency histogram. So basically when you apply the frequency histogram, it calculates the pixel number. So just we try to calculate the pixel number. Just run it. So just call the merged. Okay, basically it restored the transition, this variable merged. And we find out, you can see total 16 properties, and it is a pixel number. Okay, so you can see 101, 1471 pixel number convert. 102, how much pixel number convert. 100. 103, how much. 108. 104, how much, we find out. Okay, basically what is the 104? 104 mean that vegetation to build up. Okay, what is the meaning about the 103? Mainly vegetation to sandland, vegetation to water. Okay, how much number pixel convert. Vegetation to vegetation, how much pixel number. So it showed that all of those we can find out. 101 to 404, all of classes pixel number. So when you apply the frequency histogram, we can easily calculate the pixel number. but in this case we also calculate the area. Okay, suppose transition area. Okay, for the same we just apply the calculate the area. For that, just take a variable, suppose area image, and I apply this e dot image dot pixel area. Mainly it's calculate the area in square meter. When you divide it with this value, we find out the result square kilometer. Add bands, just call them merged. Okay, merged, because I want to calculate for each classes area. Basically 101, 102, 103, 104, then 201, and it's stored the merged. This variable is stored it here. So for that, just apply these things and run it. Okay, so previous class we also discussed about that. Suppose this type of chart we can easily calculate it. We already know about that, but sometimes chart is not work. Then we need to apply the new things how we can easily calculate the area without chart. Okay, so let's go ahead and discuss about that how we can easily calculate the chart. Uh, because sometimes chart is not work. So let's go. Okay, suppose in this case I want to calculate for this land use land cover map how much water, cropland, vegetation, banana build up without chart. Without chart, we try to calculate this area. So for that, just take a variable, suppose chart. Okay, and then call this e dot image dot pixel area. So this is the function. So this function when we apply, then we find out the result in square meter, but I want to calculate the result in square kilometer. So just put here the divide function and apply 1 into 10 to the power 6. Okay, then put here the add bands. Okay, so always these things you try to add which variable stored this map. Okay, which variable stored this land use land cover map. So just try to check it which variable stored this land use land cover map. So you can easily find out this variable is that, yeah, basically, yeah, LULC. Okay, so when you add the map.add LULC, then this map appear it. So this LULC, it stored this land use land cover map. Just copy this variable name and then paste here. Okay, sorry, LULC. Okay, just write the variable name which variable stored this land use land cover map. So in this case, LULC, this variable stored this land use land cover map. So that's why I simply put this variable name LULC. So now calculate the area. So just take a variable. Okay, you can put any name. I put the, suppose it's area. You can put any name as a variable. Take the variable, suppose area calculation. So just call this area, and when you calculate anything for a specific boundary, we have to use the function reduce region all time. And if you check what is the argument, just search here reduce region, so we find out. So just put here, or if you want simply import in here, just click on here. So first of all, reducer. So basically reducer is that I want to calculate the total area. So put here e dot reducer dot sum. Okay, but in this case I want to calculate this sum total area for all of classes, for all of classes. So for that, it's a group. Okay, so just use a function dot group. Okay, and if you check what is the group function argument, simply search at the group, mainly group field and group name. Okay, so just apply it, or if you want you can simply import from here. Just click on here, just apply the group field and group name. So group field always 1, and group name, it's different on your class property. If you check it, class property is the class. For my code, I simply copy and then apply this group name, so it's a class. And then geometry it's your shapefile variable name, which is ROI. Scale is that 30 meter. Okay, and then it's not need, just remove. Okay, for the big star area, we also need to mention about the max pixel value. Suppose I put here the 1E13 tile scale. Okay, just I know it's not must need. Okay, so now further, if I just print this area cal, just copy and paste here, click to run. So now it computed the all of area at the same time as the dictionary. So you can check total 5 elements, mainly 5 class. Just for the, you can see 0 mainly water, how much area we find out. Also you can see the 1, then 2, then 3, then 4. Okay, so sometime chart is not work, then we try to put it normally and check the area. Okay, so this same code also use in here. If you check it, so same code we also use in here, you can see. Okay, just I call the area image and apply the reduce region function. I want to calculate it for total. I want to calculate the total for each transition. Okay, suppose 101, 102 is transition. So for that, just use here the group function. Group field is the one, and in this case group name, because in this case this group name come from this transition. Okay, you can see basically it's from the merge. So just put here the transition, because if you check it, we find out the transition. Okay, or you can see the band name is the transition. Okay, this transition including the 101 to 404, all of classes, transition classes. Okay, for that just put here the transition. But when you work with for the land use land cover, then group name, just put the value or class property name. Okay, group name will be property name when you work with for land use land cover classification. Okay, you can see in this case property name is that class, so that's why we are put here the class. But when you work with for this transition, then find out the transition band name. So in this case, if you check, it's a transition, so that's why just group name will be transitions. And further print, then you can easily get the area. So you can see we find out 101 how much area, we find out that. Then check it 102 how much area, then check it 103 how much area, then check it 104 how much area, we find out. Okay, so all of transition area we can easily find out. 201 how much area, then 202 how much area. So it show about that all of transition area is class to another class, we can easily find out from here. Okay, so now it shows as a dictionary. Basically it's called the nested list. If you check, it's a list, and when I click on this list, then we find out the another list. Okay, so this type of things we also find that we also modify. Suppose it just show the value only for the transition, and also show the only for the sum, mainly total value. So then it look more perfect. So but in this case it show the as a group, and in this group we find out the list, and when I click on the list, then we find out the value. But it also more better if you just take only for the transition, only show the transition value, and then show the total value. Okay, without this type of list or group. So for that we need to just use this code. Basically just we need to apply a function, and this function will extract the information for each classes. Okay, so let's go try to apply it. Okay, so anyone any question about it, you can ask me for calculate the area. Any question?
Yes, in the chat.
Okay, this video. Okay, so basically change detection we do for the two decade. Okay, only for the two decade. Suppose 2000 to 2020, we just take for the two decade land use land cover. Okay, suppose 2000 to 2010 you can do, then 2010 to 2020, then you can also do for the 2000 to 2020. So change detection we can do for that two decades all time. Okay, for the we just compare two scenario. Suppose 2000 to 2020, suppose 2000 to 2010, 2010 to 2020. Okay, so that's why I need to multiply all time using this 100. Okay, and then you can find out that transition. Okay. Okay, so let's go.